Hello everyone, I am Harsh Khattar, working as Assistant Professor in Department of Computer Science at KITE Group of Institutions, Ghaziabad. Welcome to the lecture series of Computer Networks. In previous lecture, we have seen the roles and responsibility of data link layer. Today, our focus is on the medium access control. If I discuss about the medium access control, so there is an important concept of channel allocation which we have discussed in the last class. I have given one scenario to you that if multiple users are there and you are finding the solutions so that no conflict should be there, then which approach you will follow, static one or dynamic one. I have discussed about the pros and cons of both in the previous class. Today, we are starting these models. These are the three major components or three categories in the medium access protocols. So, this is the random access, then controlled access and channelization protocols. Channelization protocols are those where we are channelizing the things with some rules. Then next one is the controlled access, where we are controlling the things based on the mutual consent of all the faculty members. If I am taking a same scenario of students and class, so channelization means we are discussing about the resources. Controlled access, we are talking about the faculty members who are available, means the devices which are in the network, they are mutually discussing these things. And random access protocols are those where there is no such consent of any faculty member, means there are 6 faculty members who are teaching in a class and any faculty member is going in a class any time, there is no specific timetable. So, first we are taking the concern of the very first and the simplest method, which is the channelization. Then we will discuss about the controlled access and then we are discussing about the most random one, that is the random access protocol. So, in today's class, we will discuss about the first two, channelization and controlled access, and then we will discuss about the in next class random access protocols. So, first and the basic thing is channelization. What exactly channelization is? It means we have limited resources. How you are resourcing in such a manner so that multiple users can use these resources in an efficient manner. The same scenario I am taking, that there is a class of 60 students and 6 faculty members are taking different subjects in it. So, how this channelization is helping in to understand the concept. When we have a channel which is divided into the multiple users. So, this is the important concept to understand, that there is no conflict and collision in data transfer. We are allotting the channels in such a manner. If in a timetable you will see first class is given to 2 subjects, what will happen? In a very first class, 2 faculty members are standing inside the room or outside the room and waiting for the students. Now, students are also confused, yes, this is a lecture of faculty 1 or faculty 2, means we are discussing about the conflict. There is a conflict in the data, there is conflict among the faculty members that who will take a class. So, channelization says there must be a proper defined format or proper defined channel utilization, that first this faculty member will take, second this faculty member will take, so that there is no such collision. So, we are going to study these 3 concepts, 3 categories: FDMA, frequency division, TDMA, time division, and CDMA, code division, with the help of same example of students and the faculty members, so that you can understand these 3 concepts in a layman's language, and then we will discuss these in the technical terms. When we talk about the first thing, the first example, it means we are saying we have a time slot and the time is in the x axis, you can see here, this is my x axis and I am defining the time and various frequencies are divided. what it means, like you can say there is a FM which we generally listen in the cars or the vehicles. At the same time you can switch to any of the frequency is defined, and based on the frequency you can listen a particular song. So, this is the example of frequency division, means various frequencies are there, suppose 90 hertz, 100 hertz, 104 hertz, or these are the megahertz or kilohertz frequencies which we are listening. So, in this case you can see channel number 1 is at 91 kilohertz, or channel number 2 is say 95 kilohertz, or channel number 3 is on the 98 kilohertz. So, here we are discussing about the frequency, and based on this we are defining the channels. So, one particular user is assigned by one frequency channel. Here at the same time you can switch to the user 1, user 2, user 3 or user 4, and here the 4 frequencies are assigned in this manner. Now, take a same example in a class. If we are discussing about, yes, you are listening to me, at the same time you are using your earphone where the frequency is different. At the same time it is up to you, you are using the earphone or you are using your mobile phone, or you are listening to a faculty member. So, in a class you have multiple options. At the same time you can see this thing, yes, the frequency is defined, it is up to you that you want to opt for which user. So, this is a frequency division. This is a very simplest and the traditional approach which we are using in the networks, frequency division multiple access. In this, for instance, these channels, suppose the frequency band is 13 kilohertz and we are dividing it among the users. Suppose there are 2 users, so this frequency band is divided into 2 parts. This is 13 kilohertz, so if we divide it into 2 bands, so it will be 6.5 kilohertz each. Similarly, if I am dividing it into 4 parts, then it will be something 3.25 kilohertz each. Okay? So, this is how based on the users the frequency bands are divided, the frequency channels are divided. So, suppose we are talking about the telephone example here. So, in telephone style manner we can say that we have X frequency and we are dividing it into the receiving end and the transmitting signal as X by 2, X by 2, which is completely makes X. So, this is my original frequency channel which is divided into 2 parts. Now, what is the issue with this FDMA? Frequency division multiple access says if we are increasing the number of users, the frequency is divided into the much smaller parts, and if there are so many parts, then the frequency interference, the signal interference is there. So, there is a issue of interference, the frequency will conflict. We have also experienced this thing when we are switching to the FM, then at some point we have seen, yes, the signal is not appropriate at a particular frequency, and at a particular frequency we are facing the 2 sounds, means there is some sort of interference. So, this is a issue under the FDMA. For this we are using the band guards, means we are wasting some of the frequencies which is unutilized. Suppose I am saying 1 to 90 is used, then 90 to 100 is unused, then 101 to 200 is used. So, there is a difference of 10 which is a band guard which removes this frequency interference. So, this is another thing which is what is the solution in this and how we can overcome this. So, for now this FDMA and the division of frequencies, the multiple frequency bands to the multiple users are given and they can use it at a same time. So, this is very important line to understand, this block is very important. Next one is time division multiple access. This is the same example of your timetable. Yes, the frequency is same, means the faculty will come here on the dais, it is not required to use the mobile phone or earphone or Bluetooth you are using to listen the different frequencies. No, now you are focusing only on the dais of the class where the faculties are coming and going. Means first lecture is given to faculty 1, second lecture faculty 2. It means the whole 8-hour schedule is divided into 8 slots. Basically, we are talking about these time slots in your timetable. So, your timetable is the best example of TDMA, time division multiple access. Here in TDMA, its available time is divided into the time slots with the same radio frequency, means the frequency is same. We are not tempering any frequency range is same, but we are dividing the time slots. You can see here, yes, this is a time, yes, this is a faculty 1, faculty 2, faculty 3. Suppose now we are repeating it, faculty 1, faculty 2, faculty 3. Similarly, in case of users, the frequency band is same, the primary channel splits into the 4 time slots, the frequency is same, just the time slots are dividing. Okay. So, if there are 4 users, so the time is defined, now the network is free, user 1 will send the data, time is over, user 2 will send the data, user 3 will send the data, user 4 will send the data. So, 4 slots are defined. This is the example of TDMA, time division multiple access. Same frequency band is there to multiple users at different time slots. So, time slot is different. Another example is, another category in this is CDMA. Now, what is the meaning of CDMA? This is an interesting one, the newer one in comparison to the FDMA and TDMA. CDMA says that we are assigning some codes, and these codes are only understandable by the sender and receiver. We have mutually consent. The classroom is same. You can just understand this concept like in a classroom. We can say there is a faculty member, suppose I am speaking this thing in English, another faculty member is there with say language Hindi, another faculty member is there with say Spanish. Now, the people who are at the receiver end, if they are able to understand English, then they are listening my voice only. Okay? Means they are unable to understand the Hindi and Spanish, or might be the 4th faculty member of French is there. So, they are only focusing on English, means a code, a mutual consent is there that the code is English, and if I am saying something in English, you are receiving it. Similarly, if a person is sitting in a class who receives only Hindi, then his focus is on the Hindi, not on the English, Spanish and French. Might be there is another group of users who are only able to understand the Spanish. So, the codes are defined at the same time, multiple codes are defined. So, in the figure you can say yes, the frequency is same, everybody is speaking loudly, the frequency range is same. I am focusing on English, might be my friend is focusing on Hindi, another one is focusing on the Spanish, and everybody is speaking loudly, but you are able to understand only English. So, you are focusing on this particular code. So, this is known as the code division multiple access, that the multiple users are accessing the resources based on the defined codes. So, you can see here a 3D representation that this is the time, this is frequency, and at the same time and frequency multiple codes are defined. So, might be you can treat this as English, as Hindi, and this is Spanish. Okay? Now, focus on this. Like unlike FDMA, CDMA has very same frequency for the transmission, no multiple frequencies are required. Unlike TDMA method, CDMA transmits individual time slots simultaneously at a same time slot multiple user can access. So, this is the advantage over CDMA and TDMA. I would suggest that just make a note in your copy and list out the differences in a tabular form like FDMA, TDMA and CDMA. This will help you for the university exams. So, here multiple codes to the multiple users are assigned at same time and same frequency. This is about the channelization protocols. Now, coming to the second category, this is again an important one, which is controlled access method. Here the importance or the basic idea behind this is the mutual consent of all the users who are available in the network. In a same scenario, if I am saying yes, we are talking a scenario of a class of 60 students and 6 faculty members. So, these 6 faculty members have their mutual consent and they are defining the time slot that who will go in the class. No timetable is there, no channelization is there, only a mutual consent is there. So, this is known as the controlled access methods. In controlled access, the stations consult one another to find which station has a right to send the data. It means the 6 faculty members will decide that who will go in the class for the first lecture, and in a same manner the subsequent lectures will be scheduled. A station cannot send the data unless it has been authorized by the other stations. It is not possible that in first class always I am going without the consent of remaining 5 faculty members. No, this is not in the rule of controlled access methods. So, how we are defining these rules? We have 3 rules in this. One is the reservation method, another one is the polling method, and another one is token passing. Let us have a look to 3 methods. Yes, these are very simple to understand. Just have a look to the scenario, assume it, and focus on the network, how the computers are doing these tasks. So, generally these type of examples are there, and based on these the methods are generated, how the conflict can be removed. So, very first method is known as the reservation method. In reservation method, everybody is reserving its slot. Okay, today I have a content of 2 lectures. So, I am reserving the first 2 lectures, or after lunch 2 lectures for the computer networks. Might be compiler faculty is saying no, last night I was not at the hometown, I was in some function. So, today I will not take any class. So, means the reservation says first you need to book a slot. Based on the slot you are taking the classes, and everybody is consenting this thing. Suppose the third faculty of software engineering is saying yes, I also need 2 lectures, I am saying I also need 2 lectures. So, there is a conflict, but everybody out of 6 they are saying okay, there are 8 lectures. So, first to software engineering, next to third and fourth to the computer networks faculty member. So, there is a mutual consent over this. This is known as the reservation method under the controlled access. In this methods, the station needs to make a reservation before sending the data. It means before going to the class we need to reserve the slots. Okay. In the figure you can see here, this is the first frame. In this, out of 5 faculty members or out of 5 stations, only first one has reserved the 1 slot. That is done. After this, in the another cycle, the same 5 stations are there, and station 1, station 3 and station 4 wants to send the data. So, yes, it is okay. So, here a complete reservation is there. Okay, first packet goes to you, or first we are giving the slot to you, second slot to second faculty member, third slot to the 5th faculty member, because third and fourth faculty member do not want to take the class. So, here if there is a common consent, then there is no chances of collision. If everybody is discussing about okay, the first lecture is of this subject, second lecture is of this subject, so at the end of the day there is no conflict and the smooth conduction is there. So, reason is all station agrees on which station is the next to transmit the data. This is known as a reservation method under the controlled access. I hope now you are unable to understand, that why reservation is required. So, in reservation we can easily say that there is a mutual consent of all the faculty members who will go next in the class. So, there is no conflict. Similarly, in technical terms, if we are taking an example that the 5 users or 5 stations are there is a mutual consent who will send the data. So, they are reserving their slots before sending the data. Once the slot is reserved, okay, now you can send the data. So, this is reservation access. Another important one is polling method. What is polling method? Polling method says that there is a particular primary station, like we have a concept of class coordinator, and class coordinator will decide okay, first lecture yes, faculty A will go, then faculty B will go, faculty C will go. In previous one we have the mutual consent of all n faculty members or n systems who are present in the network. So, if in a network there are 100 stations, so it is very tough to take the consent of all 100 stations. So, here we are creating one owner, yes, you are known as the primary station, and other 99 are the secondary stations. What primary station decides will be followed by the all secondary stations. Okay. So, this is the difference between the polling and reservation. Reservation means everybody is giving their consent. Polling means there is a central authority, he will say, okay, you will take a class, you will take a class, you will take the second class, you will not take the class, like this. So, here in the polling, as I said, it depends on the topology, and the primary station will decide when the access will be given to the secondary stations. Now, what are the roles and responsibility of the primary stations? The roles and responsibilities are control data transfer, so there is no collision. Give control to the secondary station who will transmit the data now and for the next packet, and primary node initiates the session. So, the session is also initiated by the primary node, because first the primary node will send the packet to all nodes that who wants to send the data. Okay, and based on the consent, primary node is saying, okay, first lecture will be going to the faculty A, then faculty B, like this. So, yes, there is again the same thing, because everybody is agreeing to the major one, which is the primary station. So, there is no such conflict in the data. In the diagram you can see here, this primary station will first send the poll that who wants to send the data. So, if a station A say, yes, I want to take the first class, okay, first class goes to you. Might be primary one is saying to the B, yes, you want to send the data, he is saying, no, I do not want to send the data. So, here the acknowledgement is treated as the negative acknowledgement. Just focus on the diagram, say this is the class coordinator and this is a faculty A, and class coordinator asks to the faculty A, do you want to take the class? And faculty A is saying negative acknowledgement. Negative acknowledgement says no, means I do not want to take a class. So, in this case primary one will receive this negative acknowledgement, this is known as NAK, negative acknowledgement. Then the primary one will send the request to the B, and B will say, yes, I want to take a class. So, once that class is taken, then the primary will again ask. So, here it is not required to take a consent of everybody, no, only the primary one will decide who will take the class, who is the owner of the class. Another one, the third one is the token passing. This is again a very good approach, which is generally asked in the, you can say out of these three, token passing is the more important than the reservation and polling. What is saying about the token passing? Token passing says, yes, 6 faculty members are there and we are passing this marker and duster. The faculty who is having the marker and duster will take a class. So, this is simply a token, or a bag is given to them, yes, it is carrying the marker and duster and you can go to the class. In a class only one token, only one marker duster should be there. Okay? So, here this thing we are representing it as a token, and this token is circulated among all the faculty members. The faculty who is having a marker duster will go to the class. Once he will out, he will pass the marker duster to the second faculty and he will go. So, here yes, there are some issues, it is up to the first one that he will pass it to which one. So, generally we represents the token passing in the ring topology, so that if the first station is in the class or first station is using the network, it will pass it to the second station. It is not like that again first station is coming here in the loop and first and second they are swapping the lectures only, and station 3 and station 4 are sitting ideal. So, this is not a way, there is a ring topology and they are utilizing the tokens inside this. Another issue is, if I have purchased my own marker duster, then means we can't say that duplicate tokens can be generated. So, in this case only yes, one marker duster is there, nobody will come with your own marker duster. Similarly, if a duster is damaged, then who will take a class? So, these are some concern areas. So, currently we are focusing on the concept. So, this is all about the token passing algorithm. You can refer these references, these are some of the examples are very nice in the other websites like this one, the Baju's one, and this is Study Tonight, and my content is from chapter number 12 from the data communication book by the Forozen. So, today we have discussed about the channelization, why it is required, difference between TDMA, FDMA, CDMA, what is the difference between reservation and polling, and what is the working of token passing. Now, open-ended question for you. If you are making your own network, which scheme you will prefer? The channelization one or the controlled access? Under the controlled access, which one? So, just think over the question. See you in the next class with the random access protocols. Thank you.